The thesis is really driven by the search for the unknown, and it has two subtitles. So improving standard model prediction with resummation and the status of fine-tuning in SUSY. And in the first part of my thesis, we have looked at resummation. And this is a technique that improves upon the standard way of doing calculations in the standard model. It exists already from the 80s, but what we've tried to do is really extend it in a new direction. The second title, this is about the fine-tuning problem in supersymmetry, a symmetry that you impose on the standard model, and thereby you extend the standard model with a whole bunch of new particles. You often hear that supersymmetry is a field theory and we should look ahead and we should look for something new. And I wondered how much truth there is in the statement, supersymmetry is fine-tuned. So this is the second part, and this was really driven, like I said, out of frustration. So resummation has been developed for the so-called leading power logarithms. They are the most dominant in this blowing up of the perturbative series. But there is a second class called next to leading power logarithms, because they're the next ones, are so far a bit neglected, but we were wondering, should you actually neglect them? I mean, with the increasing energy of the LHC, should we actually neglect these things? About the fine-tuning stuff in supersymmetry, we've applied it to 4 different supersymmetric theories, and then just seen what happens to it. So what does it mean for a supersymmetric theory to be fine-tuned? And on top of that, we've included the prospects of future dark matter experiments and collider experiments to see which of these experiments is the best to discover supersymmetry. Yeah, so in the first part, we discovered this new numerical method, which will really help us. And we've also been down this origin of next to leading power logarithms. So to get a little bit technical, it's the emission of soft and collinear quarks and gluons that are next to soft. These are the terms or the physical processes that will generate these logarithms. And as already told you before, we find also that their numerical effects cannot be neglected. So, secondly, in the context of supersymmetry, we found that indeed the literature contains many false claims concerning the fine-tuning of supersymmetry. When I first saw that, I was a little bit surprised, because I was in this state of mind where I thought, you know, literature is always right. Well, this turned out not to be the case. And the reason for that is not that they were stupid, but they made certain assumptions which, you know, weren't always valid. And the main conclusion of this part of the work would be that in order to discover a natural scenario of supersymmetry, all that you need to do is actually you need to look for the so-called Higgsino parameter. Click, which is an E plus E minus collider, will do the best job in just, you know, removing all of the model dependence. And yeah, this would really help us in settling this naturalness question. So yeah, to summarize, we've looked at 2 aspects of the search for new physics in my thesis. And I really hope to follow this line of research also in my further career. And I hope to live and see the day where we discover new physics.